slope. So in particular, this is going to be the slope of lines. Now, personally, when I think of slope, I'm thinking of something more like, I don't know, this right here. That's what I think of when I think of slope. But we have to bring that down a little bit more to a mathematics level. And I kind of want to get your opinion on something first. So which of these slopes do you think is steeper? This one, first one, or the second one?
Second.
First one or the second one? Which one's steeper? Which one's the black diamond run where your instructor skis, and which one's the double green where, you know, you can roll a marble down that one pretty easily. So probably the second one is the easier one. This one's a steeper one. And what you're seeing and what I'm seeing in your answers is you have kind of an intuitive notion of what a slope is. A slope is a comparison of the rise to the run. So that ratio, rise over run, is what comprises our slope. So that's where we're going to pick things up with our handout. We're going to look at this formula, the rise over the run, and plug that into some slope equations. So we'll start out with the first one is the slope of a line between these 2 points. Now, typically speaking, when we work these problems, what I do anyways, especially when I'm teaching it, is I'll write down x1, y1, x2, and y2, and then just fill all that stuff in. So see if we can't make that work. That's going to be m equals y2 minus y1 over x2 minus x1. I'm just writing it down this first time just for practice. Eventually, hopefully you'll have that memorized. Let's fill in what we get here. So this is going to be y2, which is 4 minus 1. So the difference in the y's over the difference in the x's, 6 minus 1 again. Let's see, it should be 4 minus 3. How about that? 4 minus 3 over 6 minus 1 gives me 1/5. Okay. So that's the slope of the line between these 2 points. So let's highlight that this way. There. That's going to be the slope of the line between these 2 points. 3 and 1 and 6 and 4. Okay, so nothing too dramatic there. Let's try another one. Slope of a line between 1 and 3 and 6 and 1. So that's these 2 points right here. And we'll also draw that on our little handout. That's the slope of the line between these 2 points. So who can fill this in for me this time? When I calculate this m, what am I going to be subtracting? What from what?
1 minus 3, 6 minus 1.
Beautiful. So again, you've got your x1, y1, x2, y2. So it's the difference in the y's, 1 minus 3 over 6 minus 1. So negative 2/5. Cool. But there's something worth noting about this that I want you to understand in a qualitative aspect. This slope was positive and this slope was negative. And I want you to understand and appreciate the look of these things. As you move from left to right, the positive line is going to be moving upwards in the y direction. The negative line is going to be sloping downwards in the y direction. So try and understand those things qualitatively. And let's look at another one. This next one is going to be the slope of a line between these 2 points, between 1 and 1 and 6 and 1. So that's going to be these 2 points right here. Now add a guess. Is there a lot of slope between these 2 points?
No.
No. Was your instructor enjoy skiing down that hill? Nah, probably not. Not my style. So let's see. What'd your prediction for the slope be here? How much slope is there? If it's a nice horizontal line? There's none. Let's see if the math bears that out. It's going to be 1 minus 1 over 6 minus 1. 0 over 5. What's that equal?
0.
0. All right, so that makes sense. There's no slope here. Actually, a 0 slope would be better. I don't like saying no slope. So there's a 0 slope there. We've got one more, and it's between these two right here. So let's find the slope of this one. Would your instructor like skiing down this one?
Probably not.
Probably not. Maybe with a parachute, maybe, but yeah, that one looks a little bit beyond my abilities. So let's see. M is going to be 1 minus 4 over 6 minus 6. What does that give me? What do I get when I simplify that?
-3 over 0.
All right, negative 3 over 0. Good. And what is negative 3 divided by 0? So negative 3 over 0. Can you divide by 0? No, that's the mathematical no-no. That's the don't collect $200 in Monopoly, right? You know, go straight to jail. This is undefined. You can't divide by 0. So if you wanted to say there's no slope, all right, this is where I would say there's no slope. 0 is a perfectly fine slope, but this one is undefined. So you've got all 4 of those possibilities. Now you can have various combinations thereof, and you can have slopes that are steeper, slopes that are shallow, but in one way or another, they're going to boil down to all 4 of those cases. Positive, negative, 0, or undefined. So what I want you to do, at the bottom of your sheet, I've graphed 4 different lines. I want you to label these as positive, negative, 0, or undefined based on the slopes that you see here. So I'll give you a few seconds to work on that. Okay, so let's see. Mel, how about you give me the first 2 here? What are those slopes?
Positive and undefined.
Good. Positive and undefined. Perfect. And go on, Rachel. How about the next 2?
0 and negative.
Good. 0 and negative. Thank you, ladies. Perfect. Perfect. Let's flip our handout over to the back side and take a look at something there. So I've got an equation of a line here, or I've got a line graph. I'll tell you the equation, then we're going to work with it a little bit, graph some things. So we're going to graph the equation y equals 1/2 x minus 2. I'm going to see what we can get when we graph that. Now, if you don't know what the graph is like, one of the things you could do would be to form yourself a little t-table and then just plot some points. So that's what we'll do. So we'll form ourselves a little t-table and plot some points. So we've got y equals 1/2 x minus 2. There's my little t-table here. X, y. Now, if you're trying to make this easy on yourself, one easy value to plug in for x would be x equals 0. That's not so bad, right? So I get 1/2 times 0 minus 2. Well, 0 times anything is just 0. So, great. 0 gives me negative 2. Let's try another one. Let's try x equal 1. If we try x equal 1, well, we're going to end up doing a little bit more work and maybe getting a little bit outside our comfort zone. If I put in a 1, then I end up with 1/2 minus 2, which, you know, depending on you, maybe you want to write that as -4/2 and get -3/2. But the bottom line is you get a fraction. And I know that at least some of you would be kind of unhappy with that. So let me make a suggestion here. You could plot this point, there's nothing wrong with it. That's -1/2. But most of you would probably be happier by plotting points that don't give you these fractions. So let's try and think a little bit outside the box and try and avoid the fractions. We've got a fraction here because when I multiply the 1/2 times this number, I didn't get a nice even number. So if you think about it, when I multiply these things, I'll end up dividing by 2. So if I choose something that's a multiple of 2, things should work out a little bit better. So let's try a couple multiples of 2. So the first one would be 2. We'd also have another one which would be 4. So if I put in a 2 here, you get 1/2 of 2 minus 2, which would be 1 minus 2, which is -1. All right, that gave me a nice even number. Now sometimes when you do these things, I'll ask for a couple special points. If you were to look at our first point, it's right here on our graph. It's where x equals 0. Y was -2. That's our y-intercept. So our y-intercept, you get that by setting x equal to 0. But what if I wanted the x-intercept? So that would be up here, x-intercept. How do you think in general I'll find the x-intercept?
Put a 0 for the y.
Yeah, put a 0 for the y. So just kind of symmetric to what we did with this. Set x equal to 0, you get the y-intercept. Set y equal to 0, you get the x-intercept. Awesome. It's Emmy, right?
Yep.
Awesome. Thank you, Emmy. So let's do that. So we'll set y equals 0. So I'll do that up here. 0 equals 1/2 x minus 2. Well, there's a couple ways I can work this, but for convenience, I'll just add 2 to both sides. You can get 2 equals 1/2 times x. I still need to get x by itself. How can I get x by itself?
You multiply by 2.
Yeah, multiply both sides by 2. Thank you. So I'll multiply both sides by 2. That's an x. So 2 times this, 2 times this. The 2 times the 1/2 cancels, and I get x equals 4. Perfect. So when I set y equal to 0, I end up with x equal 4. And that's nice. A lot of times there's good interpretations for where x equals 0, where y equals 0. So it's nice to find those points. But let's look back at our graph. At least this all matches up pretty nice. This is the point 4, 0, etc. But I want to take a look at the slope of the line here that's represented. Now, I kind of regret not putting in these little points in between, 1, 2, 3, etc. But let's see if we can't figure out what the slope is of this line. Now, you don't necessarily have to put in the y2 minus y1 and the x2 minus x1. You can keep in mind that slope is the rise over the run. How much of a rise is there going from -2 all the way up to 0?
2.
2. And the run, the horizontal part? 4. All right, thank you so much. So overall, the slope is the rise over the run, or 2 over 4, which is 1/2. Okay. So the slope is 1/2. Nice. And interestingly enough, the y-intercept was -2. But by some strange coincidence, I'm seeing those very numbers in my equation. I've got a 1/2 in front of the x. I've got a -2 here. Do you think that's in general just a coincidence that, okay, you know, this one happens to be my slope and that happens to be my y-intercept? Probably not. In fact, you can rely on that happening always, that m is going to be your slope, b is going to be your y-intercept. So that's nice. It's exactly what you'd like to see happen. And we're going to take advantage of that. Okay. So far, so good here. Thumbs up? Yes? All right. Thank you. Let's do a couple problems then from my little OneNote here. Let me jump up to that. Over here. So let's start out with something like this. It says, write an equation for a linear function whose graph has given characteristics. It has a slope of 3 and a y-intercept of 0, 17. So they're pretty much giving us everything we might want. And let me kind of write down a shortened version of that for us here. We'll call that example A. So, example A. So we want a slope of 3 and a y-intercept of 0, 17. Well, if you got this question on an exam, you could probably think to yourself, yeah, Mr. Parent's favorite football team probably won over the weekend. This one's easy because they're giving you everything you need. There's your M, there's your B. We know this is going to fit into y equals mx plus b. So Ryan, what's the equation for this one?
And just y equals 3x
Plus
17.
17. Yeah, done.
That was easy.
Yeah, nice, nice, nice. So they're not always going to be quite that nice. Sometimes you might have to solve for y. So such is the case as if you had something like this. Call this example B. What is the, first of all, slope? And secondly, y-intercept for 2y plus 3x equals 12. Well, you can't just go, oh, well, the slope is 3, the y-intercept is 12, because the equation is not in the right form. You've got to play with that equation just a little bit, get it in the right form. So what steps do I need to do to make it look a little bit more like that? What would you do?
Move the x to the other side.
All right, let's move the 3x to the other side. Now a quick little something that I'll remind you of. When something changes sides, it also changes signs. I mean, to really get rid of the 3x here, I'm going to be subtracting 3x from both sides. Since I don't have an x term over here, I get 0 minus 3x gives me minus 3x. So that's 2y equals negative 3x plus 12. Now I'm good, right? Slope is -3, the y-intercept is 12?
You have to get y along.
Yeah, thank you. So you got to get y by itself first. So we still have a little bit of work to do. Everything needs to be divided by 2. Even though it's inconvenient, the -3 term. It's inconvenient because it didn't really go in even. That's okay. You can write it as -3/2 x like this. Or you could write it a couple different ways. Now, where's my Photoshop? Rats. Plus 6. Or you could write it as -3/2 x plus 6. Either way, the slope of the line and the y-intercept now are apparent. So, Carvel, what would be the slope here, please?
That would be the -3/2.
Perfect. Thank you, sir. So the -3/2 and the y-intercept, want to finish it off?
6.
6. Beautiful. So the only other thing that I would need to remind you of, like I said, is that you've got to solve for y before you determine the slope and the intercept. Nice. Nice. How are we looking on that one? Doing okay? All right, thumbs up, thank you. Let's try some more. So for this next one, we're going to need a new form of the equation of a graph or equation of a line, and that's called the point slope form of the equation of a line. It's actually on your handout. So if I jump back here, it's this one right up here in the upper right-hand corner of your handout. It's called the point slope form of the equation of a line, because that's really what you need to create this. You need, first of all, a point. So you need an x and a y. Call that your x1, y1, so it's a point. And you need m, which is your slope. So you need those two things in order to come up with the equation of a line. So it'll be a line that passes through that point with that slope. So, okay, great. Let's take a look at that. Let's see. So let me do, we'll call this example C. And I can zoom out a little bit. We want to find the equation of a line that passes through the point 4 and 1 with a slope of 1/2. So, okay. So, through 4 and 1 with a slope of 1/2. Now to remind you, this is what we have to plug into. Y minus 1/2, y minus y1 equals m times x minus x1. But fortunately, we've kind of got everything we need. We've got the slope, that's your 1/2. What's x1 equal to in this case?
4.
Yeah, x1 is your 4, and y1 is 1. So everything lines up pretty nice. It's going to be y minus 1 equals 1/2 times x minus 4. Now, typically speaking, if I give you a problem on an exam like this, I'd ask you to solve for y. I want it in slope-intercept form. So that means you're going to have to distribute. That'll give me 1/2 x. What's half of 4? 2. If I add 1 to both sides, I get 1/2 x minus 1. And that should be my answer. But like a lot of things in a math class, you can check yourself. You can make sure that you got the right answer. Now there's two ways that you can check your answer in this case. One of them is if you have some technology available to yourself. So my favorite piece of technology, at least as far as a math class is concerned, is something called Desmos. It's free. Go to desmos.com, sign in, whatever, and let me plot the point 4, 1. Now, if I did things right, then my graph should pass through that point. Let's see if it does. Y equals 1/2 x. Well, close. Oh, but I got to put in the -1, and now it's perfect. So it certainly passes through that point. And if you wanted to, you could kind of figure out what the slope would be. So let's zoom in on these 2 points. If you go over a distance of 2 for the run from here to a point underneath this one, that's a distance of 2, and vertically you're going to go up 1. So the slope is exactly 1/2. What if you didn't have something really cool like Desmos in which to just graph things and look at them, but you still wanted to test your answer and make sure that it's right? How could you prove that you got it right?
Plug 4 in.
Plug 4 in for x. All right, so let's do that. So let's check it. So y equals 1/2 of 4 minus 1. Half of 4 is 2. Minus 1 is 1. And, well, that looks pretty good, right? So it passes through that point. But Jameson, I also need to assure myself that I have the right slope. That's actually easier though, right? How do I know I got the right slope here?
You could plug in both of the coordinates. Like 4 and 1.
You could maybe do something like that, but I just want to know that this line has the proper slope. What's the slope of this line? Just look at, yeah, that's just 1/2. It's right there. So it passes through this point and has the right slope. So nailed it. Good job. Good job. Thank you. All right. Let's see. Let's keep going. What if I gave you something a little different? What if I gave you a problem in which I gave you 2 points? In fact, there's one on your handout, so let me maybe look back at that. So let's see if we can't find the equation of a line through these points. So that's, kind of the first part of this question is to find the equation of line, but there's a problem. I know that at some point I'm going to need to use this formula, y minus y1 equals m times x minus x1. So I need a point and a slope, but I've got 2 points and no slope. So it's not, I don't exactly at the moment have what I need. How am I going to figure out what I need? How am I going to figure out this equation?
You could do y2 minus y1 and x.
Beautiful. We're going to start out by finding the slope of a line between these 2 points. So, cosine, right? Okay, cool, thank you. So, let's call one of them x1, y1, the other one x2, y2. So just arbitrarily x1, y1, x2, y2. By the way, if I labeled them this way and you label them the other way, x2, y2, x1, y1, you would still end up with the exact same slope. It doesn't matter which you call which. Just as long as you subtract the x's and the y's in the numerator and denominator respectively. And you have to subtract them in the same order. All right, so Hannah, what's that calculation gonna look like here?
Let's see, rise. 14 over. Wait.
You gotta do some subtraction. So it's this formula again, right? The y2 minus y1 over x2 minus x1.
Oh, okay. Okay, so 22 minus 14
22 minus 14 over,
over 10 minus 6.
perfect. So 8 over 4. And hey, that's a nice even 2. Okay, thanks Hannah. Let's see if we can't put that into, or help us get an equation now. I've got a 2 there. But I've got 2 points. Which one do I use? Or doesn't it matter? What do you think? Does it matter which point I choose to finish calculating the equation?
No.
No, it doesn't. So you can pick either one. So I'm just going to pick these because these numbers are smaller. So the 6 is going to be my x1 and the 14 is going to be my y1. So 6 there. Let's see if we can't come up with the equation. So it's going to look like this. Y minus y1, which is 14, equals m, which is 2, times x minus 6. So y minus 14 equals 2x minus 12. If you add 14 to both sides, to get rid of the 14 here, negative 12 plus 14 gives me 2. Nice. So there's your equation. There is one last part to this problem. But before I get there, are we okay with how we came up with this equation? It's a good problem to make sure you know how to do. This is the kind of thing that I would quiz you on, I would test you on. So if there's a little uncertainty, let me know. Yes?
So just making sure, you said that we can plug in either point.
Yeah. And just for giggles, then let me do this. Suppose that you, Shauna, wanted to plug in the other point. You're like, 22 is just my favorite number. It's cool. It's a product of 2 prime numbers. I like 22. So we could plug in those 2 points instead of these 2 points, or well, that point and that point. So it'd be y minus 22 equals 2 times x minus 10. So y minus 22 equals 2x minus 20. And when you add 22 to both sides, you get 2x plus 2. So the good news is it works out the same either way. You don't have to worry about which one to use. They both work out the same. What I do is I pick whatever's first or whatever looks more convenient. If one of these or if one of these pairs of points has easier numbers, pick that one, right? Why not? So good question. Good question. All right, so there was one last part of this, and that is find y when x is 19. So, okay. If x is 19, what does y equal?
Okay.
Well, let's find out. So I'll plug in a 19 for my x. 2 times that is 38. plus 2 gives me 40. Nice. So the backstory on this, if those of you who ever played Words with Friends, I used to play with a guy who was an editor for Cengage Learning, and one time he remarked, he's like, well, you know, you'd probably do better if this was a math game. And I started thinking, I'm like, yeah, I'll start using some math here. And so these little things here, these little meters tell you how good your score is. So I got 6 bars and a score of 14. Here I chose a better word. I got 10 bars and a score of 22. So how much could I get? What score could I get? If you wanted all 19 bars, you could get a maximum score of 40. So I could judge, you know, how close am I? Do I really want to work that hard to get that maximum score? So, any case, the thing that I'd like you to be able to do is to find the slope of a line between 2 points. So that's probably worth doing something like that again. Let's see. Let's choose 2 different points. And I think that, let's see, yeah, these 2 points right here. -2, 1, and 2, -5. So it'll be our next pair. So -2, 1, and 2, -5. I'll switch my camera in just a second. So we want to find the equation between these 2 points. And I'm going to want that in slope-intercept form. On an exam, I try and say that, like on every problem where I care about it, but that's pretty much my default. Basically what that's going to mean is that after you get your equation, you want to solve for y. You want to get y all by itself. All right, so give you a little bit of time to work on that. Feel free to help each other out. And if you're watching this later on video, you can fast forward until I unpause. Isn't that a cool pause button? That's just amazing. Oh, wait. Stop. Once you find the slope, you might be helping yourself out if you put it in lowest terms. Changed it. So if you want to borrow a calculator, I've got some that you can borrow. I ask that you leave keys or a phone. That way we both get back our stuff at the end of class, but more than welcome to. I find keys in the phone are things that people don't get far without. Thank you.
Thank you.
All right. Let's see how this one's going to work out. So first thing we're going to need is the slope, which is your y2 minus y1 over x2 minus x1. If you fill that in carefully, it's going to be negative 5 minus 1 over 2 minus negative 2. The thing to be careful about is the double negative there in the denominator. That's going to simplify down to negative 6 over 4. Since those are both even numbers, I hope you take the time for yourself to divide out the 2 and end up with a slope of negative 3/2. So that's the first part. So that gets you a couple points, getting the slope. Another couple points is if you drop it into this equation correctly, so y minus y1 equals m times x minus x1. So once again, we've got all the stuff we need. We've got the slope, you've got your x1 and your y1. So let's plug all that stuff in. It's going to be y minus 1 equals negative 3/2 times x minus negative 2. And again, you got to be careful with that double negative. In fact, let's clean that up. How does that double negative clean up?
Plus 2.
Yeah, it becomes a plus 2. And I like the idea of cleaning that up before I distribute. So when I distribute, I get y minus 1 equals negative 3/2 times x. What's going to happen when I multiply a negative 3/2 times 2? Well, if you're unsure, if you're uncomfortable with these things, look, take out a calculator and do it. I mean, I'd like for you to be able to do these things in your head, but if you're not comfortable, you can just take negative 3 divided by 2 and then multiply it by 2. All right, so you should get negative 3. But like I said, if it's not really in your comfort zone, don't get it wrong because you're being too proud. So minus 3. So that's another couple points. And then finally, add 1 to get it in slope-intercept form. That is, you solve for y. And bingo. Y equals negative 3/2 x minus 2. Question?
Yeah, I have a question.
Yeah, go ahead.
Wouldn't it equal, because wouldn't it be a positive, because you have a negative 6 and then a negative 4?
But it's not a negative 4. It's a positive 4.
Positive, positive.
Yeah, because you had 2 minus negative 2. Remember, when you're subtracting these things, they always have to be in the same order. So it's negative 5 minus 1 in the numerator, and then 2 minus negative 2 in the denominator. So when you do that, that double negative becomes a positive. But there's a different way to look at that and realize that the slope has to be negative. Suppose you were to graph that and take a look at that. So let's put up a couple points on the board here. So negative 2, comma 1, that's 1 point. And then 2 comma negative 5, that's the other point. So just looking at the graph, what kind of a line has to go between those? Is it going to have a positive slope or a negative slope? Yeah, it has a negative slope. So if you were to take time to look at that, or at least think about the graph, you'd realize, oh, it's got a negative slope. Let's check it out one more. Y equals negative 3 divided by 2 times x minus 2, and bam. Nailed it. Goes through both points. So, cool. I appreciate the question. Thank you. Anything else on that one? Let's do one or two more. So kind of venturing away from just, just some abstract stuff here. Let's try something like, actually, you know what? I do want to do one problem before I get to a nice application here. So, example D. Find the equation, and I'm going to abbreviate that EQN. Oops, let me switch over here. Of a line through point 5, negative 31. You know what? Let me make that. I'm trying to see where I can squeeze it in. I want a horizontal line. So we're going to have a horizontal line through the point 5 and negative 31. Let's see if we can't figure out its equation. Or maybe know the equation, that's great. If you do, great. If you don't, we'll figure it out. So right here, I want to find the equation of a horizontal line through that point. And if you know this, it's a quick one-liner. If you don't, and you're stuck figuring it out, then you're going to have to think about, well, one of these formulas. Y minus y1 equals m times x minus x1. And at least the nice thing about that is you got a little bit of a head start. You've got your y1 and your x1. But what am I missing? What information am I missing if I wanted to actually fill in this formula?
The slope.
The slope. But am I missing the slope? Am I really missing the slope? What's the slope, Pearl?
There is no slope.
I'd say I choose my words a little different. I think you're right, mean the right thing. Zero?
Yeah.
Yeah, thank you, ladies. 0. Yeah, it's a horizontal line. So the slope is 0. So, okay. Let's fill in all the information then. It's going to be y minus negative 31 equals 0 times x minus 5. 0 times anything is just 0. So it's y plus 31 equals 0. Or in other words, y equals negative 31. Yay. So pretty simple. If I asked you a follow-up question, find the equation of a line through if I horizontal line through 7 and 48, do you need to go through all this stuff again, or can someone just jump to the happy ending?
Y equals 48.
Y equals 48. Horizontal lines are always going to be y equals something. How about if I wanted a vertical line? So this is the point 5, negative 31. What if I wanted a vertical line here? I'm not going to be able to get at this in the same way that I did just now, because this, what's the slope of this vertical line? Undefined. So, all right. But in many ways, this is just as simple as this equation. But I don't have a horizontal line, I've got a vertical line. And I want to guess what the equation is here.
X equals 5.
X equals 5, yay. So if you've got a vertical line, it's X equals something. If you've got a horizontal line, it's Y equals something. This slope is undefined. This slope is 0. Perfect. Perfect. Okay. Let's do another one. So do a couple of kind of nice applied examples to round out the section. Let's see. So let me show it to you over here, and then I'll kind of copy down the bare bones essentials. So in a proposal to some prospective clients, a housing contractor lists the following costs: fees and permits, miscellaneous, $12,000. Construction per square foot, $235. So a couple things. Write a linear function that you could use to determine the cost of building a home, having so many square feet. And how many square feet could you build if you were to spend $482,000 on a house? Let me add a kind of a third one in here. Let's kind of squeeze one in between. How much to build? I don't know. How big do you want your house? 3,000 square feet? All right. Square foot house. So let's see if we can't figure out those things. Let me write down some of the essentials here for us. So we'll call this example E. Example E. Fees, permits, miscellaneous, $12,000. Cost per square foot, or construction per square foot, $235. So the first thing is to write an equation that represents all this. Now, let's let X be the number of square feet. So X equals the number of square feet. And I know that you think that that little thing is a hashtag. I grew up different, sorry. It also stands for number. So it's the number of square feet. And I'm going to put that in the form of y equals mx plus b. But which one of these is the slope? Which one of them is the intercept? Jocelyn?
235 is the slope, and then the 12,000 is the B.
Good. So 12,000, that's your fixed cost. That doesn't change regardless of how many square feet you build. That's just fixed. So you're paying that even if you build 0 square feet. The 235, that is going to change the price depending on how many square feet you build. So thank you. And thank you, Emmy, for also volunteering. So there's our equation. Great. All right. How much is your dream home of 3,000 square feet going to cost? Is that in the budget for you? How would I figure that out?
Multiply 235 by 3,000, and then you would add the 12,000.
Perfect. So if X equals 3,000, we're going to plug that in here, multiply by 235, and add 12,000. I think you're going to need a lot of cash, somewhere north of 750. So let's see here. 235 times 3,000 plus 12,000. I was off a little bit. All right, so $717,000. So wow. So 235 times 3,000 plus 12,000 equals 717. So a pretty good pile of cash to come away with a 3,000 square foot house. So maybe your sight's a little lower. Like, you know, I don't got quite that much money in the budget. So let's set our sights a little bit lower. Suppose you say, you know what? Here's my budget. My budget is $482,000. Yep, so my budget's $482,000. How big of a house could I build? Now what are we gonna do? So this is part C. The budget equals $482,000.
Like $482,000 for Y.
Yeah. Go ahead.
Will we have to subtract the initial costs from that as well? In order to see how much we have left after that in order to get
Yes.
those sort of like-
And that all kind of falls out if you plug this in for Y, because that's gonna be your cost. And you're exactly right, we will end up subtracting the miscellaneous part from it. So we're gonna plug that in for Y, that's 235X plus 12,000. So you're right. What's the first step we're gonna do? Subtract 12,000, right? So that comes right out of your budget before you start calculating any square foot. It's like, all right, gotta pay those fixed costs. Now we're left with 470,000 equals 235,000. To finish solving, divide by 235, and you get a little bit more modest house of 2,000 square feet. So kind of working things backwards there. Nice. Nice. We're gonna do one more like that, but if there's some questions on this one as it stands, something about that maybe I went over a little too fast, reach out, let me know. Caitlin, doing okay on that one? Shauna?
Can we see part B one more time?
Sure. So for part B, all we did was we took our equation here from part A and plugged in 3,000. All right. Okay, so let's kind of zoom up and look at this one right here. Let me put that on a different page so I can zoom in on it a little bit, make it a little bit easier to read maybe. And let's do 20. All right. So baseball club pays a vendor $115 per game for selling bags of peanuts for $5.25 each. So basically you're paying, that's how much you have to shell out, and you're gonna get back in return $5.25 a bag. Write a linear function that describes the profit the vendor makes for the baseball club if she sells B bags of peanuts. How much profit does the vendor make, or does that should be the club make, if they sell 90 bags? How many bags must be sold to earn $640? Let's put in a part D. How many bags must be sold to break even? All right, so a lot going on with this one. But let's start out by writing an equation, and instead of a y, we're gonna use a p, and instead of an x, we're gonna use a b. So, just a little bit of a change there. But can we write an equation that represents, what's going on here? Ian?
Y equals 5.25x plus 100.
We gotta be careful. I have sympathy for what you said, but in thinking about this in my morning class, I realized that that's not quite right. So to repeat what Ian's got going here, and we're going to work with it just a little bit. So we'll call this example F. So A 525 or 5.25x plus 115. So let's switch over to here. 5.25x plus 115. That was my initial reaction when I looked at this problem. So we're in the same boat. Then I thought about it a little bit more. That 115 is not profit for the vendor or the baseball club. They got to pay that money. So it starts with a K. Colby, yeah.
Wouldn't that be 640 if they have to break even?
Actually, I think the break even is a little bit different. Sarah?
Can we subtract 115 because they're losing the money?
Yeah, they're losing that money. They have to pay that money, so it's not really profit. So let's go to the variables that they were asking us to use, which would be your profit is $5.25 per bag, but then they got to pay the person to sell these things, so you're going to pay $115. Okay, so now that we've got this, that's our first part. Let's see if we can't answer some other parts. But this was the tough part. This is the part that when I first read this problem, I didn't really appreciate that. Oh, you got to lay out $115 to begin with, and then hopefully you'll sell enough bags to kind of catch up, right? We'll figure that out as the last part. Well, the next question says, well, if you sell 90 bags, how much profit do you make? So now what are we going to do?
You put
Justin?
in 90 for B.
Yeah, plug in 90 for B. Awesome. You guys are making me look good. Thank you. Appreciate that. Extra credit all around, right? All right, so let's put in 90 for B. And it should be 300 and something. So let's take a look here. So 525 times 90 minus the 115. So $357.50. Good. Good. So Colby, here's your part of the equation, or here's your question relating to the 640.
And you say 640 is equal to,
Yeah, so it says how much money or how many bags must be sold to earn $640. So, okay. What should we do, Colby?
you say 640 is equal to 525 times E minus 150.
Perfect. Basically, you're going to put in 640 for your profit right here, and then see what we can solve. I hope this works out. 640 equals 5.25 times B minus 115.
Wouldn't you have to wouldn't you have to add 115 because you're gonna
Yep.
have to subtract.
You're going to have to add 115 to both sides, so we'll end up with 755 equals 5.25 times B. And then finish it up by dividing by 5.25. So 740 divided by 5.25. Uh-oh. 140.95. So can you sell 0.95 of a bag? No. Sterling, question?
How much was it originally? You said it was 640 originally
If-
before we did the 115.
So yeah, we wanted to make a profit of 640.
Okay, I was just confused because you had wrote on that paper 740.
Oh, did I write 740 here?
Yeah.
Let's see.
Plugging in the calculator, you plugged in 740 instead of.
Oh, did I plug in?
Yeah.
Oh, yeah, I should have plugged in 755, shouldn't I? I don't know where I got the 7. My bad. Thank you. So let's try it again. 755 divided by 5 5.25, 5.25. Still not working out nice and even, but that's okay. We can work with that. Yes?
I was about to ask that next, will we just round up?
Yeah, so since you can only sell a whole bag, you know, selling 143 would be a little bit short of what your goal would be. So you have to go to 144 to make sure you get a little bit more than the desired $640 in profit. So yeah, you'd round up in this case. So good question. So about 144 bags. So you'd round up. And I'm kind of glad we ran into that problem here because we're going to run into it again, I think, in the last problem, part D. Part D is like, all right, well, what's the break-even point? I mean, how many bags do you have to sell to break even? Can anyone tell me what your profit is if you break even? Sure.
0.
0. Your profit would be 0 if you break even. So that's going to be 0 equals 5.25b minus 115. So I'm just going to finish solving it here. Add 115 to both sides. Divide by 5.25. And I don't think it's going to be a nice even number. But that's okay. 115. Divided by 5.25. So if you could sell 21.9 bags, that would be perfectly break even. But you can't sell partial bag. At least I wouldn't take one anyways. So you'd probably round that up to about 22 would be pretty close to the break even point. Nice, nice.
I have a quick question about that.
Yeah, Colby.
So if you run into this on a test or a quiz or something, would you want us to say, do you want us to put like an approximation sign?
Yeah, that's nice. I'm glad you caught that. I mean, this is not an equals, it's an approximately equals. So there's a couple ways you can write approximately equals. So you can write it like with squiggly lines, or you can do equals with a dot above it. Either way means approximately equal. Yeah, and I'd be very happy to see the approximate symbol. It's not a requirement, but if you catch that, all the better. Thanks for the question. Anything else? All righty. Good luck with this section. It's a pretty good review of your linear equations and all the things I want you to be able to do with them. So to kind of recap a little bit, you should be able to tell me the equation of a horizontal line, a vertical line. You should understand slope and intercept. Pretty much expect a problem like this. Find the equation of a line between 2 points. All right, that's a real bread and butter type problem. Expect one of those. It's helpful to understand that when you're graphing lines by plotting points, that you can choose nice points to deal with fractions like that. So basically you want points that are a multiple of this denominator. Slopes of lines, the various slopes of lines, and of course slope-intercept form, point-slope form of a line, find the equation of a line between 2 points. Ooh, I don't think we did this one, did we? Did we go back and do this one? All right, sorry, I got everyone excited. We'll do one last problem here. We'll make it quick though. Find the equation of a line through the point 2 and 20 parallel to this line right here. So you've got this point at 2 and 20, and you want to find the equational line that goes through that point and is parallel to the given line. So what would that line be? Now, in as much as we already have a point, call it x1, y1, you might start thinking of this formula, which I encourage you to write down on the top of your test. Just write it down right there, right when you get your test or your quiz, before you forget it. It's called a memory dump. That way later when you need it, you don't have to panic, it's right there. So we've got our x1, y1. x1, y1. But what I don't have, something I need, is my slope. So what am I going to do about the slope? Colby?
Couldn't we just look at the line that you drew to see what points that intersect? And then count the rise over run?
Okay. Ian?
You plug in X, or plug in the 2 for X.
Jocelyn?
Couldn't we just see like the second equation since it's parallel, would it be like equal and thus?
Yeah, there you go. So, little reminder, little slash background, parallel lines have to have the same slope as each other, right? Otherwise, they're gonna cross. So if they're parallel, if they're never gonna touch, they have to have the same slope. Now, perpendicular lines have slopes that are negative reciprocals. But if they're parallel lines, that has to be the slope of this line so that they never cross. So basically that's telling you that m equals 8. And now I've got everything I need to plug into this equation. So it'd be y minus 20 equals 8 times x minus 2. Remember, I like you to solve for y. So if you add 20 to both sides after distributing the 8, you get 8x plus 4. Nice, very nice. How do I know that that actually works? I mean, I could graph it and see that, you know, I get a line parallel to this and going through that, I can see it visually. But without graphing it, can I prove that I got it right? That I have a line that's parallel to this line passing through that point?
See if they don't touch.
That could take a while because you'd have to look at the line forever. But they actually don't touch, and we know that. Yes?
You could plug in y in the, like what y is in the y equals x.
Yeah, we can plug in this point. So if I plug in a 2, does 8 times 2 plus 4 equal 20? 16 plus 4 equals 20. So it passes through this point. How do I know that these lines are parallel though? They have the same slope, right? You got a slope of m equals 8 here, slope of m equals 8 there. So it does everything it's supposed to. Well done.